Another important concept is the difference between population and sample. The population is everything in a particular population. So for example, all of the Norway spruce in Finland. And let's assume that all of the Norway spruce in Finland has a mean density of 450 kilograms per meter cube. We can't possibly measure the whole population. All we can do is measure a sample of that population. We can take a number of specimens from that population, and that number of specimens is our sample. So let's take 100 specimens, and then we can measure the density of those 100 specimens and use that mean of the 100 specimens of our sample to estimate the mean of the population. We won't be able to get it right because we've only got 100 as an estimator of the whole population, but we can use some statistical techniques to work out how confident we are in our estimation of the mean of the population. Another important technique is the histogram. So more than just calculating the mean, we can count how many specimens have a certain density within a certain range and plot a graph, a histogram. So we can divide or make some categories of density and count how many of our specimens have a density within that range, and on our histogram draw some bars to represent the frequency of the number of times that we've encountered that density in our sampling. So that's frequency. And if we do enough of it, if we do enough sampling, if our sample size is big enough, this histogram will slowly turn into this continuous distribution of the entire population. So the other thing that's important that we can't really solve with statistics is the question of whether we're actually taking a representative sample of randomly independent measurements of that population. If we just took one tree of Norway spruce from Finland and cut it up into 100 pieces and measured the density of each of those, then we don't really have a good representative sample of the whole population. All we have is the measurements within a tree, and all of the pieces of timber within a tree have a certain mean density, and that mean density is not necessarily the same as the mean density of the entire population. So our sample is the way of estimating the properties of the population. To get a better estimate of the properties of the population, we can take a bigger sample. So if we took n equals 1,000, we would have a better estimate of the mean than if we taken n equals 100. And there are statistical approaches that will allow you to calculate the confidence of your estimate based on the sample size and the variation within that population. Now, the one thing that statistics can't really help you with is the question as to whether you've taken a nice representative sample of that population. Are each of these specimens statistically independent from each other? If you'd taken just one tree of Norway spruce from Finland and cut it up into 100 samples, then those samples are not statistically independent of each other anymore, because a certain tree will have a certain mean density, and that will be slightly different to the mean density of the entire population. So the question of how do you do a good representative sampling? Well, it depends a lot on what you're trying to achieve, and it's a complicated subject, so I can only give you a surface level introduction. But for example, if you wanted to know the variation of density of Norway spruce in Finland in the forest, then it would probably make sense for you to do some kind of forest level segregation. So to go around different forests to identify ones with certain elevation, certain latitude, certain longitude, certain forest characteristics, to make sure that you're making a sample that is representing all the kinds of forest and all the kinds of trees of Norway spruce that you have in Finland, and then sampling the tree in such a way that you're taking a sensible average of that whole property. So if you were just taking cores, for example, you'd be needing to carefully balance the fact that the outer part of the tree, there's proportionally more of the outer part of the tree than there is of the inner part. So you'd have to take all of these things into account. If you wanted to do, though, a representative sample of timber in production, then it would be a mistake, really, to do that kind of forest-level sampling. Rather, you should actually sample industry itself, because that's the most representative way of finding out what industry is doing, is to actually go to industry and get some pieces. But if you just got one pack of timber from one sawmill of 100 pieces, as I said, that's not necessarily going to be a representative sample, because a pack of 100 pieces from a sawmill will contain many pieces from the same log, more than likely, and certainly several pieces from the same stand. So it would be better then to go to the sawmill and take every 10th piece on the line, rather than standing there and taking 100 pieces in sequence. Even better would be to go back and take one every shift. Or even better than that would be to go to 20 mills and take 5 pieces from each of those 20 mills. Now, the issue of whether you've done a good representative sample or not is not something that you can, unfortunately, answer with statistics. It's something that you answer with some scientific knowledge of how the industry or how the forests are growing.